Let's talk about lung volumes, and I suppose we're looking at here the amount of air that enters and exits the lung, right? How much we breathe in and we breathe out. So to kick us off, I want to immediately start with not a definition, an equation, okay? I know you guys can't get enough of equations in your GCSE, so let's see if we can do that here. We've got minute ventilation, more of which I'll define in a second. Minute ventilation, which I'm going to keep in purple here, and that equals, something called tidal volume. Again, I'll express what these things are to in a second. Something called tidal volume, and just reflect on what you think that might be. Multiply by breathing rate. Breathing rate. Sometimes we use the term breathing frequency, or even sometimes just frequency. Just be aware of that. In fact, if we were using the symbols here, this would be F for frequency, so just be aware of that. I'm not going to get into that today. So before we go any further, let's just define what we are talking about. With minute ventilation, we are talking about a volume. I've already got the wrong purple. We're talking about a volume of air in and out of the lungs per minute, okay, per minute. That's what minute ventilation is, okay, and we measure it in litres, okay, so just so you're aware. Now, if you're interested, or if you want to think about it yourself, actually pause the video here and try to therefore define what tidal volume and breathing rate must be, because they must be two specific values to contribute this volume, okay? So if you want to pause, do that now. But assuming you have, or indeed if you haven't, I'm going to go on to define these things. Well, we know what breathing rate is. We're talking here about total breaths per minute. Okay, so how many times we breathe per minute, basically. So total breaths per minute. That is frequency. Okay, and that's, and breaths per minute is our unit there, effectively. Just be careful with BPM, because we use that for beats per minute when we're talking about cardiac stuff. And tidal volume, what must that therefore be? Well, tidal volume we will define as the volume of air, got the right colour this time, the volume of air entering and exiting the lungs, entering and exiting the lungs per, what am I going to say, guys? Lungs per, I'm sure you know it, per breath. It has to be thus, doesn't it? Because the number of breaths multiplied by the depth of the breath, the depth of the breath, put it that way, has to be how much air is breathed in and out of the lungs per minute. Now, generally speaking, we will measure tidal volume in millilitres, but of course that's convertible, millilitres to litres. I'm not going to get into the details of that today. You guys will be confident, I'm sure. Now, just a couple of things I would stress to you. Let's just think about this. I don't know if this is essential, but let's just think about these values at rest. Okay, so if we were looking at these values at rest, what would we be looking at? Well, first of all, that normal in-out breath, our tidal volume, will be in the region of 500 millilitres. In other words, half a litre, okay? Now, we're going to multiply that by the frequency of breathing. Now, it very much varies from person to person, okay? But I'm going to say that at rest, maybe think about this even as sleeping, we're going to look at something like 12 breaths per minute. We might breathe once every 4 seconds. Is that right? Once every 4 seconds? No, that wouldn't be right, would it? Once every 5 seconds. Gordon Bennett, James, maths. Now, what would that mean for our total minute ventilation? Well, we'd expect it, therefore, to be in the region of 6 litres. Now, these are average figures, okay, or generalised figures. Just be aware of it. But we're getting 6 litres in per minute. How? Half a litre per breath, 12 breaths per minute. That's how that's going to work. Now, we also want to look at measuring breath, or at least graphically illustrating. So let me bring my ruler in here. Let me get it to a nice position, want it at 90 degrees. There we go. I'm going to make a little graph here, okay? Now, this graph represents something called spirometry. So let me just quickly show you what we're going to have. I'm going to take my measure to here, and then I'm going to make my x-axis. So I've got my y, and there's my x-axis there. So let me give you some value. Let me give you some labels here, okay? So on the y-axis, on the x-axis, we are talking about time in seconds, and I'm going to represent the values that we just talked about, time in seconds. On the y-axis, really should be getting these right way around by my age, but on the y-axis, we are talking here about a quantity of air, and of course we know that's going to be measured in litres, well, it could be millilitres. Now, the point I want to make here is I'm going to take my green here, guys, I'm going to take my green, my tidal volume, and I'm going to represent this at rest to begin with. So what we'd find that someone's breathing looked like is something, and I'm just sketching, bear in mind, it would be something like this. So right now I am, and so on. So if I stay at rest, my breathing is going to continue in this way over and over again. Now, just to be clear, guys, this here is our tidal volume. That is our tidal volume, and we know already that at rest that's going to be in the region of half a litre. Okay, there we go. That's simple enough, right? That's simple enough. Now you might be wondering, well, how do we get this curve? This is called a spirometer curves. Okay, so I'll refer to this as spirometry, and I'm not going to get into the details here. You might, if you go on to do A-level, you might look at it in more detail there, but basically spirometry is where we breathe in and out of a mouthpiece or mask, and that mouthpiece, the air that we're breathing in and out, enters and exits a jar which is partially filled with water, and the movement of that jar then moves effectively a pencil to trace on a graph, and the graph paper is moving either in a circle or flat. Okay, so that's how this graph actually gets presented. I'm not going to get into the details of that here, but I want to stretch to you two further things. First of all, can you realize that this here, we could consider, I think I had the right color, we could consider this to be one of our 12. Okay, so here, look, we've got one full cycle. If we do multiple cycles here and we did 12 of them like that, that would be our frequency. Each of these represents a breath. Okay, now I'm just going to get rid of those because it's sort of going to get in the way a little bit. But the other point I want to sort of represent to you is that we can, of course, breathe more deeply. Now, what would that look like on this curve? So what we'd expect to happen here, if I just use my rubber a second, if I just sort of get rid of this here, and I want to get rid of this here. Okay, so let's just look at this middle area here. Go back to my pen. Now, what I want you to imagine is that our breath does not just peak at 500, but when we're breathing in, and the upper portions are breathing in, by the way, but it goes up like this, and when we're breathing out, we can, of course, as well force our breath out, and we can breathe more deeply like this. So this that I've represented in the middle, this is not me just at quiet breathing. This is me breathing in and me forcing my breath out. Okay, so we can represent that. Now, the point I want to make to you guys is that this is also tidal volume. Okay, but notice that tidal volume has increased by taking on additional quantity. We've breathed more in, we've breathed more out, but it's still our tidal volume, okay? It's just that the tidal volume increases during forced breathing or during exercise, so be aware of that. Finally, guys, of course, if we start to breathe faster, you would see the frequency of this wave. And guys, I know you know in physics it's transverse wave. I'm not going to get into that here, okay? But you would see the frequency of this wave sort of cluster more closely together. But the point I'd like to make to you is that when we start exercising, the first thing that happens is that we breathe deeper or more deeply. That happens first, okay? And that's a bit like this. Notice it hasn't gone any faster, it's just gone deeper. But once we're into heavier exercise, we will notice that our breathing will increase in rate or frequency, and that happens second. So what you'd see is kind of like this curve concertinaing, and you'd have higher and more frequent peaks and troughs, with the tidal volume being at a higher peak rate. I want to remind you of what we said right at the start. Minute ventilation, which is the volume of air per minute, equals tidal volume, volume of air per breath, multiplied by breathing rate. So therefore, if we increase tidal volume by increasing depth, we'll look at the muscularity of that in another lesson, and or we increase the rate or frequency of our breathing, what happens to our minute ventilation? In fact, what happens overall is that our values would increase. There we go.